Now let me start sets, relations, functions and introduction to exercise 1.1. So in this introduction part we will see what is a set and then what is the notation of the set and subset of the set and different types of sets we are going to learn, and last we will see some properties of the sets. So let me start from the definition of the set. Now what is a set? A set is a collection of well-defined objects. So this well-defined is very important because proper definition should be there. So for example, if I take the collection of all beautiful flowers in Ooty Rose Garden, it is not a set because here beautiful flowers is not well defined. Why it is not well defined means beautiful flowers means suppose if I like some kind of flowers, I think that is a beautiful flower. If somebody likes some other flower, he will think that is a beautiful flower. If somebody likes some other flower, that he will think that is a beautiful flower. So there is no criteria that certain flower is beautiful or not. So it depends on the person who looks at the flower. So that's why it is not a set. Okay. Now suppose if I rewrite this sentence like this: the collection of all red flowers in Ooty Rose Garden. It is a set because in the Ooty Rose Garden you can select all the red color flowers. So it is a set. So here it is properly defined, well defined. So this is your textbook example only. Similarly, second one, this is also from our textbook. The collection of all old men in Tamilnadu. So I want to collect all old men in Tamilnadu. That means what? There is no proper definition for old man here. Somebody will think if I reach 70 years, I will become old. But some people think 70 is the age of old man. Some people think in 50 I am feeling old. So it depends on the person. That means it varies from person to person. Perception changes from one person to another person. That's why here old man is not well defined. That's why it is not a set. But if you rewrite the same sentence like this: the collection of all men in Tamil Nadu of age greater than 70. So now it becomes a set. Why it becomes a set? Because proper definition is there, some restriction is there on the age. Greater than 70. So we can collect all the data of the men whose age is greater than 70, that is more than 70. Now in this case it is a set. Now for example, the collection of all good teachers in Tamil Nadu, it is not a set. Because good teacher, there is no proper definition. See, somebody will think my teacher is a good teacher, some other person will think my teacher is a good teacher. So it varies from person to person. There is no proper definition for good teacher. So you cannot go to every each and house and you cannot call like come out, I want to check you are a good teacher or not, whether teacher is there in your house or not. So these are nonsense we cannot do. So that's why it is not a set. But if the greater than 70, if they give the restriction, then it becomes a set. So now we completed only one part, just the definition of the set. What is a set and some examples of set. Now notation of sets. Now this part also very important. Now this also you studied in the lower classes, like 10th standard you already studied, 9th standard you already studied. Now sets can be denoted by using two forms. One is roster form, another one is set builder form. So in the roster form, like each and every element is separated by commas, like 1 comma, 2 comma, 3 comma, 4 comma, 5. So this is the easiest form. This is the simplest form of the set. And it is denoted by using letter A, caps A, capital letters we should use. If you use a small letter, that is wrong. Small letters is used only for elements. Okay. So A is a set containing the elements 1, 2, 3, 4, 5, and it is known as a roster form. Now B is equal to, now this is another form. This is set builder form. X such that X is a oval. That means we are telling something about this element X. So X, that is element in that set, but what is it describing? It is a oval. So English vowels everybody knows. UKG, LKG onwards you are studying. First standard onwards. A, E, I, O, U. So here we need to build the set by yourself. Simply they will give one condition regarding this element. So it is set builder form. That's why it is set builder form. Set, we are building the form. So we are building the elements present inside the set. Okay. Now next concept. So this is the notation of sets, which is very easy. We have only roster form and we have set builder form. Roster form, directly the elements are represented, separated by the commas, but in set builder form you must describe the element. Now subset of a set. Now what is a subset? For example, A is equal to set containing the elements 1, 2, 3, 4. B is the set containing elements 1, 2, 3, 4, 5, 6. Now I can tell A is a subset of B. This is a symbol for subset. But in this case it is proper subset. Now what is a subset means? A is part of B. A is part of B. Suppose you are studying in a school, your classroom is a part of entire school. So your classroom is a subset of school. So like that. Subset means part of. Now A is subset of B, but here it is a proper subset also. What is the meaning of proper subset? Means the number of elements in set A should less than the number of elements in set B. A lo இருக்கிற elements B ஓட கம்மியா இருந்தா அதுக்கு பேரு proper subset. But B is called a superset because some two elements are extra. That's why அது வந்து super quantity மாதிரி superset. Okay, for example, A is 1, 2, 3, 4, B is 1, 2, 3, 4. Here also A is a subset of B, but it is improper subset. Okay, so these kind of things are known as improper subsets. Now we'll see some more example for improper subsets. Okay, so now A is subset or equal to B means improper subset. All the elements are there, but they are also equal also. That's why it is known as the improper subset. Now A is subset or equal to A. Again, every set is a improper subset of itself, because every element in A also present in the given set itself. No. For example, A is 1, 2, 3, 4. Again A is 1, 2, 3, 4. So it is equal and also part. That's why it is improper subset. But don't confuse. If equal to sign is there, improper. If not there, proper. Or subset or equal to means same. That's it. So A is equal to 1, 2, 3. B is equal to 3 to 1. But in this case, you will tell A is equal to B. That means here the elements are same, but orders are changed. Students, you remember you studied this in lower classes. 9th standard. Equal sets, equivalent sets. All these things you studied in 9th standard. Okay, next we will see trivial subsets. This is somewhat important but easy only. See, for any set A, that means for any given set A and empty set phi are called trivial subsets. That means what? For example, A is equal to 1, 2, 3, 4. Then that set itself is a trivial subset, because every set is subset of itself. If you take A is a subset of itself. If you take B is a subset of itself. Similarly, empty set phi, it is also a part of the set. So that's why given set A and phi are called trivial subsets. Okay, now this is a next part. Now we saw definition of set, and then proper subset, improper subset, notation of set. Now we will see the union of two sets A and B. This is one of the operation we can perform on the sets. Now union of two sets A and B. What is the English meaning of union? Combining. Suppose A is one set containing some elements, B is another element, another set containing some other elements. Then what is A union B means? This is a definition. This is given in set builder form. X such that X belongs to A, that means that element might present in A or that element might present in B. That means you are combining both the sets A and B. So this is the definition. Now we will see some examples also, don't worry. Intersection of two sets A and B. Example, A is equal to 1, intersection of two sets. Same thing you should write here. I forgot to write here. A intersection B is equal to X such that X belongs to A and you should put, instead of R, you must put and. So the example for union and intersection. A is equal to 1, 2, 3, 4, 5. B is equal to set containing 2, 3, 4. Then A union B means you are combining A set and also B set. So it is 1, 2, 3, 4, 5. Now A intersection B. Intersection B means what? Common elements. Okay. 2, 3, 4. So in real life example, suppose somebody is playing cricket match. Some students, set of students. Ramu, Ramesh, whatever it may be. Some people, some students. B set is another students. So they can play, for example, kabaddi. So A union B means what? The students who can play cricket or kabaddi. But some people might be there, they can play both cricket and kabaddi. In that case, A intersection B is those kind of students who can play both the games. So bottom line is union means combining the sets containing all, right? You should write all the elements from A or B, but intersection means only common elements you must write. So this is easy concept only. This also you studied in previous classes and all. Now next important part, types of sets. So types of sets also somewhat you studied in lower classes. First one, empty set or null set. A set which contains no elements in it, or a set which does not contain any elements in it, is called an empty set. For example, the name of the student whose age is 70, studying in 10th standard. So is null set because 70 years already old fellow, right? So he cannot study in 10th standard. So null set. So no elements, and it is denoted by phi. This and all you know, you studied in lower classes. Now finite set. Finite, name itself indicates finite. The set which contains countable number of elements. That means here this is a finite set. 1, 2, 3, 4, 5 elements. Here finite set. 2, 3, 4, 3 elements. So if you count the number of elements in a set, then it is called as the finite set. Now infinite set. Name itself indicates non-countable or uncountable. A set which contains infinite number of elements. For example, set of natural numbers. So n is equal to 1, 2, 3, 4, 5, 6, millions, billions, trillions, whatever you want you can write. There is no limit for it. Okay, because there is no restriction for natural numbers. Even whole numbers, integers, rational, irrational, whatever it may be. So there is no limit for it. Next. So this is infinite set. Later, in the exercise some problems are given. You need to identify what is finite, which set is finite set, which set is infinite set, like that. Some problems are there in the exercise. Don't worry, we will see those kind of problems also later. Now universal set. Universal, universe, English meaning. Universe means which contains all the things. So similarly, universal set means is a set containing all the elements in it. That is known as a universal set. This also you already studied. It is denoted by U. Okay. Now disjoint set. What is the meaning of disjoint? English meaning. Disjoint means there is no common element for set A and set B. So disjoint means there is no common element for A set and B set. Then that is known as the disjoint. That means if A intersection B if you find, you won't get anything common in them. So here I give an example also. A is equal to set containing 1, 2, 3. B is equal to set containing A, B, C. Now A intersection B, there is no common element in these two. So it is called as a which set? Disjoint set. Now very important concept known as power set. So this is very important concept. Now we will see something about the power set. So what is a power set? Power set means what? Oh, power light will be there, set will be called power set. It's not like that. Power set means a set which contains all the subsets. That means for any set, if you write all the subset, then it is called as a power set. So power set is denoted by P of A. For example, here A is equal to set containing the elements 1, 2, 3. So if you want to write the power set for this set, okay, power set P of A is equal to, you should write all the subsets of this given set. Now I already told there are two subsets known as a trivial subsets. Trivial means what? Empty set and also the given set. So first two trivial subsets we can write, because empty set is a subset of every set. Similarly, the given set is a subset of every set. So these two you can write very easily. Now what about other things? You take single element. So set containing only one, that is one subset, because it is also part of this one. Now set containing 2, that is also subset. 3, so these 3 are subsets that containing only one element. Now next one you see the 2 elements. 2 elements means 1, 2 is one subset, 1, 3 is another subset, 2, 3 another subset. You should not change the order. 1, 2 is wrote, if you wrote, you cannot write again 2, 1. That is wrong. Okay. So you count now how many subsets you can write the power set. 1, 2, 3, 4, 5, 6, 7, 8. That means what? Suppose here 3 elements are there, we are getting 8 subsets. Suppose 2 elements are there, suppose 3 is not there, you will get 4 subsets only. Because empty set containing 1, 2, 1 is separate, 2 is separate, that's it, only 4. That means what? That means what? Here 3 elements are means 8, 2 elements means 4, 4 elements means 16. So it is 2 power n. 2 power n. So the formula which is used to find the number of subsets is 2 power n, which is very important. 2 power n means 2 cube, because here the n value is 3. So for this set 8 subsets might be there. Now singleton set, it's very easy, name itself indicates singleton. Singleton means only one element. If somebody is seeing the movie, okay, in a theater, singleton set, single element. For example, A is set containing only 2, so only one element is there. But null set is different. Null set means nothing is inside that set. Nothing is there. Okay, that is known as a null set. But singleton set, only single element. For example, 2. 2 is only the even prime number, okay, present in the universe. Okay, that's why it is a 2. Next, complement of a set. A complement, A dash, or AC also you can write. AC நம்ம யூஸ் பண்ணி AC கிடையாது, இங்கே AC. AC means A complement. அப்போ A power 1. Both are correct only. Some books use AC, okay, some books use A dash. Everything is correct only. Now A dash is equal to set containing X. X belongs to U. U means universal set, and X does not belongs to A. That means அந்த எலிமெண்ட் யூனிவர்சல் செட்டில் இருக்கணும், ஏல இருக்கக்கூடாது. So like that you should write A complement. So A complement means a shortcut U minus A. Okay, that is the meaning of this statement. Present in universal set but not in A set. Okay, now set difference. Set difference A dash almost same model. A minus B is equal to A, such that A belongs to capital A and A does not belongs to capital B. That means that element should present in A but not in B. A lo irukkanum, B lo irukkodadu. One example I will teach. It's simple only, you already studied lower classes. Example, U is equal to 1, 2, 3, 4, 5, 6. A is equal to set containing 1, 2, 3. B is equal to set containing 2, 3. Now if I want to find A complement, so it is denoted by A dash. A dash is equal to, what is the formula I told here? U minus A, U minus A. So it might present in universal set but not in A. So what are the other elements which are present in U but not in A? 4, 5, 6. Because in early classes you studied strike all the common elements. 1 is strike there, 2 is strike, 3 is strike. So what are the leftover here? Leftover element 4, 5, 6. So A dash 4, 5, 6. So A minus B means the elements present in A but not in B. So it is a set containing only 1, because you see here 1, 2, 3, 2, 3. So here 2 is strike off, 3 is strike off. Okay. B minus A means here in this case if somebody asks B minus A null set. Because there is no extra element present in B which is not in A. So you should not confuse. The elements present in first set but not in second set. Similarly, A complement means the element present in universal set but not in A set. Okay. Now next one. So we studied empty set, that is null set, no elements in it. Finite set, countable number of elements in it. Infinite set, non-countable number of elements in it. Universal set, which contains all the elements present in it. And disjoint sets, they don't have common elements in it. Power set is a set which contains subsets of the given set. All the subsets you should write. But how many power sets are possible? How many subsets are there in power set? It is given by the super duper formula 2 power n. So 2 power n means here 3 elements, 2 cube. Now singleton set, single element in it, only 2. Complement of a set, U but not in A minus B, present in A but not in B. A dash, U minus A minus B, present in A but not in B. Now we will see the cardinality of a set. What is the cardinality of a set? This also is studied in lower classes. The number of elements containing in a set is called cardinality of a set. For example, A is equal to set containing elements 1, 2, 3, 4. What is n of A? 4. This A represents the set. This n represents the number of elements present in A set is equal to 4. 1, 2, 3, 4. Suppose if there are 3 elements only, n of A is equal to 3. 2 elements 2. Suppose A is equal, 5 is equal to 5, empty set. Now what is n of 5? 0, because 5 is empty set. Okay, like that also it should not confuse. Okay, number, how many? Suppose in your class if 20 students are studying, n of section A is 20. Because 20 people are studying. Okay, now next one. Symmetric difference. This is a very important one. This is symmetric difference. Then we will see some properties. Okay, first we will see symmetric difference of set A and B. Symmetric difference, 2 formulas are there, but this is a very easy formula. One more formula also we will see, later I will tell. Symmetric difference means symmetric difference of A and B is denoted by A delta B, which is nothing but A union B minus A intersection B. How will you remember now? Bigger set minus smaller set. Area set minus putty set. The bigger set A union B, because A union means we are combining the elements from A and B. So it is always bigger. But A intersection B, common elements. So it is smaller. Okay, so bigger minus smaller. Like that you remember, it's very easy for you. Okay, area set minus putty set. So bigger set minus smaller set. Cardinality of sets. Cardinality, okay, of sets. Some formulas they are given. These formulas also is studied in lower classes. N of A union B. N of A union B is equal to N of A plus N of B minus N of A intersection B. That means N of A means number of elements present in A set. N of B means number of elements present in B set. N of A intersection B means number of elements present in both A and B. So this is the formula. Suppose if you know 3 things, you can evaluate this one. If I know these 3, I can evaluate this one. If I know these 3, I can evaluate this one. If I know these 3, I can evaluate this one. So unknown quantity you can find very easily. So this is only for 2 sets. 2 sets. Suppose if 3 sets are given, then what is the formula? N of A union B union C is equal to N of A plus N of B plus N of C. That means A plus B plus C minus AB minus AC minus BC. 1, 2, 2, 3, 3, 1. So A intersection B minus N of A intersection C minus N of B intersection C. This one you can write here also. That doesn't matter, up to you. AB, BC, CA or AC. That doesn't matter. Plus N of common part for all the sets. A intersection B intersection C. Okay. So last part in this sets, we have properties of sets. That I will present in the next video. Okay students? Okay, bye.